Very good. So I'd just like to give you the very rough outlines of our corpus, Fremic, and I'll be talking about three main topics. So I'll give you a little bit of background on multimodality as such. Then I'll show you how we're building Fremic, and then I'll point out three possible research avenues based on Fremic. So as Anne has already touched upon, most corpora tacitly subscribe to a speech-only view in that they filter out anything that is not a word and transcribe the spoken language merely orthographically. But this view, this speech-only view, is fundamentally incomplete for the simple reason that the words we say are just one component of a larger system of bodily expression. And speech is really just the tip of an iceberg, riding on a deep infrastructure of nonverbal modalities. The modalities that we have at our disposal to communicate with one another include the verbal modality, which is speech, the vocal modality, which is the huge realm of the prosodic variables that we have at our disposal, and then certainly not a smaller repertoire of the kinesic modality, which includes gesture, facial expressions, posture, gaze, etc., etc. And all of these modalities really work together as one integrated multimodal communication system. It's also interesting to note that evolution has equipped us and our body optimally for multimodal communication. Our hands have been freed for gesturing, right, by bipedal locomotion. Gaze direction is easily detectable thanks to the white sclera around the eyes, which is not present in animals. Here is a picture of my late, I have to say, dog. It's always been very difficult to see really where he was looking at, whereas this is much more easily done in humans. We also have a very rich nonverbal toolbox, if you will. We have 43 muscles in the face. That's an astonishing number. I would think they're tiny, but still very, very numerous. And each hand has 34 muscles. So that's a huge toolbox, really, that we can draw on. And the lack of facial and bodily hair renders even small muscular movements visible and thereby communicatively effective. Right. The three modalities form an evolutionarily stratified system that has accumulated over 2.5 million years, and language gradually co-evolved with the pre-existing gestural and vocal modes of communication, so that the different modalities are deeply intertwined, so you can't tease them apart. They're always one package. And that deep intertwining of the nonverbal and the verbal modalities is never fully repressed. That can be seen very clearly in deaf signers, who, when using their sign language, also will use the mouth and even vocalize. And if you probably more readily accessible will be the example of us speaking on the phone, because there we continue to gesture, although the gestures are not visually accessible to our addressee. So, and that intertwining facilitates cross-modality. In other words, we have the remarkable flexibility to shift the burden information from one modality to another. Right, not moving. Yeah, now it's moving. In response to this relatively obvious fact that a speech-only view is ill-conceived, in recent years, a number of multimodal corpora have been constructed. There is the Bielefeld Speech and Gesture Alignment Corpus, SAGA. There is the Nottingham Multimodal Corpus, NMSC. There is the relatively large corpus of academic spoken English case, which might be relatively relevant to you guys, because this, as far as I know, is a corpus of video of Skype conversations, right? And well, then finally there is our corpus, the Fremic, on which I'd like to give you a short introduction just now. Okay, so the basics, really. We're doing transcription in Elan, and as far as I have understood you guys correctly, that's your aim as well. At present, we still have only a limited number of video recordings available at 20 hours. That is, we are transcribing them in Elan, which is a really fantastic transcription tool. It's specifically designed for multimodal interaction design, for multimodal interaction research. And the beauty of this and the power of Elan lies in the fact that you can define a tier, what is called a tier, for any behavioral aspect that you might be interested in. This can be speech, all kinds of speech. This can be gesture, this can be gaze, this can be anything, really. So there is no limit to the number of variables you might be interested to look at in your transcription. And another very helpful thing is that every annotation, anything that you insert on any tier, that is, any annotation comes with an exact timestamp. And from that timestamp, you can calculate start time, end time, and duration. So temporal data, which in spoken conversation, in interaction, is key. We are using two types of transcription. We're starting off by elaborating an orthographic transcription. That's what we call the base transcription, and that is exclusively done by native speakers of English, because our recordings are of native speakers of English. On top of that, we build, or on the basis of that, we build the CA style type of transcription that records not only the verbal content, but also interactionally relevant details. These include details of sequencing, such as overlap, latching, temporal aspects, such as pauses, acceleration, deceleration, phonological aspects, such as intensity, pitch, stretching, truncation, voice quality, laughter, and also freestanding silent gestures. On the right-hand side, you see a still from Elan, and I've pointed out the orthographic tiers there. We have three speakers in this still here, A, B, and C, and the orthographic tiers are the upper ones, and the CA style transcriptions there are below them. In this small little still, you cannot see a great deal of differences, but maybe you can spot one or two symbols which are used in the CA style transcription, which are not used in the orthographic transcription. So obviously, I'm sure you guys have a very good idea of what CA style transcription looks like. We are largely using a purist, if you like, Jeffersonian transcription, with a few exceptions. A few exceptions include freestanding laughter, which we only transcribe as an event because we've come to the conclusion that it's not worth the effort, really. It's a huge effort to describe laughter, denoting every laughter particle, and that doesn't pay off, really. And emphasis, obviously, is a very important feature of the spoken language. Normally, it's done using italicization in CA transcripts. That doesn't seem to be possible in Elan, so we've replaced it by the exclamation point. We also have annotation for a smallish kind of phonological phenomenon, which we refer to as the tone light phenomenon. In English, you would say the musical scale phenomenon. That refers to a continuous upward or downward glissando in speech. I'll play you a quick clip. This is the way the sound, the way that I do. So there's this glissando upward. There is no convention for that in CA transcriptions, but we've encountered this frequently enough to award it convention of its own. On the right-hand side, you see the transcription conventions that we're using. Overlap is signified by square brackets, latching by the equal sign, etc., etc. I don't think I have to go through this in more detail. Okay, so we have an orthographic transcription. We also have a CA transcription. On top of that, we also have an extra tier for every individual speaker for quotes. That has to do with my very central interest in storytelling, and doing quotation, doing constructed dialogue is a key feature in storytelling, and that's why we've come up with the idea of also transcribing quotes. Quotes obviously are referred to in the literature by a number of terms, not all of them meaning exactly the same thing. So you can have direct speech or free direct speech, constructed dialogue, or people working in the CE paradigm refer to it as reenactments. So we have exhaustive transcriptions of all of these quotes, both on the verbal tiers, and that includes both the orthographic and the CA type tiers, and we have their own. We have quotes on their own tiers for each and every speaker. And the reason why we chose to also put it on a tier of its own is that only then do we obtain exact temporal data for the quotes, right? If it's just contained in a larger annotation of an utterance, then you don't know exactly how long that stretch, which is the quoted speech, really takes. So you have no possibility for working with that in any quantitative way. I'll play you a short clip for that.
And then recently I've been thinking about studying again because my life is actually not like I need something. So I was looking at like courses in Strasbourg, and the whole time I was thinking, yeah, my French isn't good enough.
Right. So as you can see on here in utterance, we have it in the whole package of the full utterance, and then we have lines where just the quotes are picked out and shown in isolation. Okay, but we're not stopping there. We're also interested in silent quotes. And also, actually, this is the wrong header here. This should say silent gestures, right? Silent quotes are just a subset of the silent gestures. And silent gestures really occur relatively frequently. So both in the orthographic and the CE style transcriptions, we have explicit transcriptions of silent gestures that are gestures which are not accompanied by speech. Now, I'd like to show you an example here to make you aware why this might be beneficial. So here, speaker B, sitting on the left-hand side, is relating a scary incident where she was followed by a stranger in the night in somewhere in a town in Alsace called Metz. And look at how she's describing the streets that she was followed through by that stranger. So she's saying like, and then she's performing a silent gesture and then saying, you know, dark, narrow streets. But if we look again at the gesture, she's doing this zigzagging gesture, right? And that adds a new meaning component, namely the streets are then not only narrow and labyrinthine, but they're not only dark and narrow, which she verbalizes, but they're also labyrinthine. So you're dark, meaning you can't see properly. They're narrow, you have difficulty escaping somebody who wants to attack you. And they're labyrinthine, meaning you can very easily get lost, not find your way out of it. So this is a dramatic addition, actually, to this storytelling. And that's why we're also transcribing these silent gestures. Okay, now that's what we're doing in Elan, right? obviously, our aim is to compile a corpus. So we need to go out of Elan and put all these transcriptions together in a corpus. Where are we doing this? We're doing it in R, right? But the way from Elan to R is not an easy one. It's not a very short one because post-processing Elan transcriptions haven't really been thought through by the people who came up with Elan. I think, I'm not sure, maybe I'm totally wrong. So on the right-hand side, you can see the options that you get when you work in Elan. It's quite a number of options that are available. But having tried out almost all of them, we've come up with the decision that we want to use the traditional transcript text option. But in order to post-process that in R, you have to, this requires a multi-step coding procedure. The first is pretty straightforward. You read in the file into R, and then you do a little bit of cleanup concerning whitespace, and then you have to extract the distinct variables into columns of a data frame, and that requires a lot of regular expression. I'm just showing you the code for that particular step, which is just one tiny step, I have to say, in a long list of code. Right. And what you get from this kind of thing is a nicely structured data frame in which every variable has its own column. So we have a column for the file, a column for the line, a column for the speaker, for the utterance, for the orthographic transcription, and we have the timestamps. Okay, but this is still just the kind of embryonic part of the corpus. Because based on the timestamp, we find it necessary and very helpful and indeed critical to many research questions to compute the start time, the end time, and the duration. So if you want to have any quantitative idea of the duration of gaps or duration of quotes or utterances or backchannels or any combinations thereof, then you need to know when does it start, when does it end, and or how long does it take, right? And that again requires a little bit of data science, but this is totally straightforward. Actually, it doesn't look as if it was straightforward, but in reality, it is. Okay, we're still going further because we also want to have pause tagging, which is a standard feature of most corpora that we are accustomed to. We are inputting the orthographic transcriptions into the clause web tagger shown in the right-hand screenshot there. This is completely free and it works perfectly fine as long as you don't exceed the 100,000 word limit, right? If you were to input, for example, something like to be or not to be, obviously that doesn't show up in conversation very often, then you would get a string such as this, right? So repetition of the words followed by underscore, followed by the C7 part of speech. Again, we want to integrate this new information, this new variable, the pause tagged utterances, into our corpus, and that requires yet another data scientific step, if you will. But the end result then looks like this. So we end up with the utterance, with the orthographic transcription, and the C7 pause tagged transcription. Okay. Well, obviously, all I've been saying so far relates to the verbal modality. Our aim is to construct a multimodal corpus, so we need to move beyond the verbal modalities. One way to do this is by looking at gestures. So we're also doing gesture annotation. We're basing our gesture annotation on Kendon's taxonomy of phases for gestures. We are only doing this, or have so far only been doing this, for select storytellings, not for the whole corpus. This would be impossible because it is very, very time-consuming. We annotate for these select storytellings gestures in Elan on 2 tiers. A tier which we call the G tier, the gesture, which records the whole gesture as such. And then we have a new tier for each and every gesture, which we call the P tier, which is for the different phases here. Now, according to Kendon, gestures can have 4 main phases: the preparation phase, where the movement is from the home position in the lab, for example, to the stroke position. Then the stroke itself, which is the phase of the excursion in which the movement dynamics of effort and shape are manifested with greatest clarity. Then there is the optional hold phase, in which the articulator is sustained in the position at which it arrived at the end of the stroke. And then finally, there can be a movement back to home position. Okay, again, we are trying to integrate all of this information into our data frames. Needless to say that this involves a lot of data science, but it's possible and it's, I think, beneficial. Right. In addition to that, I'd just like to inform you that we are also doing an annotation for gesture expressivity. This is done on the I tiers. There we have 5 variables, so we look at each and every gesture and 2 raters, at least 2 raters, possibly or ideally more than 2, look at one and the same gesture independently and rate it according to a number of variables. Right. We're not stopping with the gestures. We're looking to integrate more multimodal data. In order to get hold of this data, we are using Empatica wristwatches and eye tracking glasses. The wristwatches produce psychophysiological data, such as heartbeat or temperature or what have you. The one variable we are most centrally interested in is electrodermal activity, EDA. Some people refer to it as GSR, because EDA is indicative of emotional arousal. Emotion is a central component of storytelling, which brings me back to my initial research project, really. Now, the eye tracking glasses obviously provide eye data, but they provide 2 types of eye data. They track the foveal vision, so that is the center of where people are directing their gaze to, and they provide measurements of pupil size. The foveal vision is indicative, obviously, of gaze direction, right? But the pupil size is indicative of cognitive intensity. So how much your brain is working, right? Whether it's in a relaxed state or whether it's in an effortful state. And that is quite interesting. And I'll show you at least one research possibility that we're pursuing based on this data. A little more on the eye tracking technology we're using. The eye tracking provider that we are using is also providing what is called an AOI technology. AOI refers to area of interest. Now, that's very helpful because that is what allows you to track certain gazes to certain objects or certain targets, if you will, automatically, instead of having to do it manually, which is what my colleague at Freiburg, Peter Auer, has been doing for years. This works by this relatively complicated technology involving markers, which you can see here on the chests of the subjects, and polygons. These polygons need to be drawn into all the eye tracking videos, post hoc, by the way, so no need to do it beforehand. You can do it afterwards, after you've made the recordings. You can change the polygons in any way you like. It's very flexible, And the result of the combination of markers and AOI polygons is that you get this automatic recording of gazes to what you have defined a priori as AOI, as an area of interest. Okay, now we have all sorts of data, right? We have ELAN data, we have EDA data, which is the data from the wristwatches. We have eye tracking data, the data from the eye tracking glasses, and we have this pupil data also provided by the eye trackers. These are all independent and heterogeneous data streams of different origin, and that poses a huge problem for anybody who wants to bring all of these data and sources together in a corpus, and that's what we want to do. And there is another little difficulty that comes with this. Eye tracking, and especially EDA and pupil observations, may count in the thousands per minute, whereas an utterance in conversation may take a few seconds, right? So you end up with, I don't know, up to 20 or 40 utterances per second, which is a time unit in its own right, per minute, sorry. But for the same minute, you have thousands of observations in these other data streams. So there is a huge difficulty in how to bring all of these data together. Now, luckily, all of these data streams have something in common, and that is timestamps. So based on the underlying time measurements, all of these data streams, ELAN, EDA, ET, and PP data, can be joined and synchronized in large data frames in R. This is, I can assure you, anything but trivial, and it does involve a large amount of coding, but it's feasible. And if you guys were interested in anything of that kind and order, I'd be more than happy to share our small little expertise that we've gained in that area with you completely for free. I've had the intention on showing you what the end result looks like, but I'm not going to do it because I would have to exit this presentation, which turned out to be very difficult. So just believe me that the corpus that we end up is really huge, consisting of many, many columns and ending up with hundreds of thousands of lines. Okay, now a few possible research directions. If I still have the time, I have no idea of how I'm doing time-wise, but do interrupt me if my time is really up. So I'd like to just very quickly point out something related to gaze and reenactments, or quotes, if you like, emotional contagion in storytelling, gaze selection and processing intensity. Now, gaze and reenactments, the background to this idea is that there is evidence that gaze behavior during quotations or reenactments is patterned in very distinctive ways. For example, in response, so this distinctive patterning may be, for example, in response to the need to demarcate the beginning and ending of reenactments. That's what Signal came up with as a result. And or changes in the character viewpoint, right? Whose communication is depicted? Is it my own words that I relate to my present interlocutors, or somebody else's words, or somebody else's words directed to another third person, etc., etc. No research so far on gaze behavior during silent quotes. That's an interesting thing. And we do have, as I noted earlier, annotation of silent quotes as well. So here is just nothing by way of any results, right? We haven't started this investigation even, but this is a possible way to go ahead. And that's something that I have in mind that I'm planning on doing in the near future. Here we are simply seeing one utterance by speaker A directed to speaker B and C. And we have here a split screen video So in this panel, you see the room camera video, and all the other three panels are showing the eye tracking videos. So this eye tracking video would be the one taken by speaker B, this one here, right? And the rest follows accordingly. And on the right-hand side, you see what I refer to as a speech gaze transcript, where we have in these two rows here, the one utterance, right? It's split into two halves because it's pretty long, and underneath you see the gazes, and further down here you have the four reenactments separately, and you can see exactly where A's the speaker's gaze goes. Here, for example, during that silent facial gesture, where she's just producing a blank stare, she's first looking at speaker C. Then the gaze wanders off a little bit, so off from the AOI polygons, and then back to an AOI, but not the same speaker, but the other speaker. So there is a shift from speaker C to speaker A. And now I'm going to play this, and hopefully you can see.
And I'm like, and she was just like, you can't go in. I'm like, I'm a woman. She's like, no, you're not, you can't go in.
Okay, good, wonderful. If you want me to play it again, this is the speaker's eye tracking video, and the cursor is the foveal vision, right? So where she's looking at. So observe how her gaze wanders between the two speakers and two different directions there. So I'm playing it again.
And I'm like, and she didn't. And I'm like, and she didn't.
Okay, right. So this is one thing that we can do, right? So we can look at we can combine our two data streams, elan transcriptions and gaze, and more specifically in the elan transcriptions, we can have a look at quote transcriptions. Now, another thing we are looking into, and something that I've actually already presented in a number of conferences and also started a publication, is this study on emotion contagion in storytelling. The background to this is a very conversation analytical view of storytelling, where there are three factors defining storytelling, if you will. The first is that the storyteller takes a stance toward what is being reported and makes the taking of a stance by the recipient relevant, this is a view really where, unlike Labov, who just looked at what the storyteller was doing and saying, here we're looking at what is happening between storyteller and recipient, right? And there, the notion is really that the storyteller produces and makes visible, or even verbalizes, or otherwise multimodally communicates a stance toward the events he or she is reporting, and makes the taking of a stance by the recipient relevant. So there is this give and take by storyteller and recipient. So if you will, there is a sense of there must be some kind of stance contagion going on, right? So the storyteller infects, if you will, the recipient with his or her stance. And the second idea in conversation analysis, that effective stance is performed multimodally through intonation, gesture, body posture, and what have you. And right, so if you accept the idea that the basic interactional pattern in storytelling between storyteller and recipient is that kind of stance contagion from storyteller to recipient, and if you accept the idea that stance is really a kind of emotion, which is, by the way, a tricky notion, but this is off the record, so to speak. But if we accept it for the time being, then we can say, well, actually, then there should be emotion contagion going on, right? And that's what we're looking at in this in this research project. And here, what we're doing is we're comparing two stories. One is called Toilet Woman, one is called Sad Story. And we're simply plotting the EDA measurements, right? We are defining here, or we're showing here scatter plots that show the EDA amplitudes for each participant. The storyteller's amplitude is in the top row, right? And the color coding, the story segments are color coded. Our hypothesis is that the stance contagion or emotion contagion will take place not anywhere during the storytelling, but precisely where it would be expected, and that is around the climax. So we're looking at that segment specifically. And you can see very clearly from this plot already that you see a very you see a very clear leap, upward leap here. So this is really a spike in electrodermal activity, which translates into emotion arousal. And you see a similar, well, not spike, but an uptick, a very clear uptick, which is also statistically significant in that recipient here. In the other story, there is a little bit of an uptick here in the storyteller, but there is a smallish kind of uptick in resonance, if you will, with the storyteller in that recipient, but there is nothing by way of an uptick in that recipient here. And we're investigating how all of this variation comes about, right? Why is one recipient infected and not the other? And why is there hardly any infection going on in this storytelling, whereas there is a lot of infection or contagion going on in that storytelling? And to get at that question, we are triangulating the EDA data with pitch, gaze, and intensity. Here, for example, on the left-hand side, we see pitch during Toilet Woman here, and we can see that the storyteller's pitch really goes up where it would be expected to go up. It has its climax during the climax, right? And the gesture expressivity is quite dramatic in the same storyteller's gestural behavior. And we're also looking at gaze direction, obviously, and so on and so forth. Here, for example, in this still, which plots all the gazes during this particular storytelling, we can see that the storyteller is looking primarily at one recipient, but he's not looking at that guy, for example. There are just a few sparse glimpses at that person, very, very short, but the main attention is really to that particular recipient. And that, we are hypothesizing, may play into the lack of contagion that we're seeing in the EDA plots. But there are a great number of other factors as well. Okay, and finally, to give you an idea on the third possible research direction, gaze selection and prosthetism intensity, the background to this is the fact that recent research on gaze in QA sequences, multi-party interaction suggests that gaze is a key next speaker selection technique. In the vast majority of cases, the next speaker, who is the first answerer, is also the participant gazed at by the participant asking the question at the end of the turn, right? But this is just co-occurrence, right? This is one thing happens and at the same time something else happens, right? This is a correlation, but what might be more interesting to get at a causation, that is, at this point, we don't know whether the answerer answers because he or she was last gazed at, and hence sort of feels selected. We have no idea whether that is the case, right? We would have to be able to look somehow inside of their head. And that's what we can do by bringing bringing in the pupil data. And we've come up with this hypothesis, the differential pre-answer intensification hypothesis, which says already during the question by the questioner, there should be an increase in processing activity in the last gazed at recipient, who is also the answerer, and that increase should be greater than in those recipients that were not last gazed at and that do not answer. And I've already done the study to some extent, so we've come ahead quite a bit, and the results are, in a way, quite supportive for that hypothesis. And that, I think, could bring us from correlation a little bit closer, at least, to causation. And I'm just giving you a short glimpse of one question-answer sequence, which is exactly according to the hypothesis. We have here the same trio of people, where speaker C, this person here, asks, "What's the mountain for you?" and also points very clearly to the person she wants to have the answer from. So the gaze selection couldn't be clearer here. And in this case, you would really expect that B's cognitive attention relaxes, because she's definitely not called upon to produce an answer. And that's what we're seeing very clearly in these graphs here, where the last gazed at recipient's pupillary activity, that is A, intensifies. You can see this line goes up, and it's a linear regression line behind of it, and that is a positive slope. Whereas for the questioner, the cognitive effort, so to speak, is in decline, and the same goes for speaker B. There is no uptick in cognitive activity here, but there is one, as expected by the hypothesis, by this speaker here. This is, at the moment, not fully elaborated, but I think this is a very promising research avenue.
What's the mountain for you? I don't know, Schrammsand is a small mountain. The house.
Okay, so, right, concluding remarks, last slide. The Freiburg corpus is really in its early stages, as you may have noticed, and like any multimodal corpuses or corpora, it faces multiple challenges, but I'm hopeful it opens up exciting avenues for research. And at any rate, I'm really hoping that it might serve as a model that can be used, or that can be taken some guidance or inspiration from by others.